Hello everyone, and welcome back to the series where I build a graphical text editor from the ground up, starting from just the terminal. Today I am going to be showing you the draw buffer that I made recently. So buckle up, because it's going to be a lot more than I normally do in a single video. Now there are a couple things that I haven't completed yet, things like sideways scrolling and some performance optimizations that I'll get to when I show you guys the source code, but for now this works well enough for me to continue and work on something else. Now, just for a little bit of explanation, for those of you who haven't been here before, prior to writing the draw buffer, I was basically just printing out the text as it was stored in the text buffer and had a really kind of clunky way of managing to scroll up and down. Now, this strategy worked okay, but it had a lot of problems. I couldn't really represent non-printable characters, and characters like new lines and tab characters couldn't be represented in any way other than just how they are represented by default. So I couldn't change, for example, tab width. I couldn't insert any kind of character to represent them. It was just as they were, and that was that. I also couldn't provide any kind of styling or highlighting for the text. I couldn't insert any kind of inline hints like from an LSP. And scrolling up and down was technically possible, but just not very good. And so the draw buffer fixes that in conjunction with a bunch of other code that I wrote. And the basics of how that works is, so a draw buffer is essentially very similar to how a GPU will stage pixel data. So in a GPU, you've got pixel data that's stored in VRAM, and in a draw buffer, you've got character data that is stored in memory. And so what that means is that I can insert information into there from the text buffer, but I can also insert other things very easily. So if I wanted to insert a character in place of the tab character, then I can do that relatively easily. And so this solves most of the problems that I was having before, and I'll just go ahead and show you guys the code so that you guys can see exactly what I mean. So here we are in the header file for textbuffer.hpp, and you'll notice that things look a little different here. That is because I'm currently using the new version of the editor. So we're currently in the draw buffer. I can move around, up and down. Up and down are still a little weird just because they're still using the same basic system that I had before, but with the new draw buffer. Now you'll notice this little bit here, I've got this character in place of the tab, and the tab is only 4 spaces wide instead of 8 spaces wide as a standard. And so I can move around. This tab character here is also a different color from the rest of them because I can set that up fairly easily. And so that's what this looks like. Now, if I continue scrolling down, you'll see that the page scrolls down a bit, but then I can stop scrolling down and the page stays in the same place. So the frame or the page or whatever you want to call it doesn't move unless the cursor is at a certain point within the page. So that's basically all the things that I was trying to work on for this episode. All the features that I wanted anyway. So I'll go ahead and start explaining some of the code here. So first off, I have this char color enum, and that just stores all of the colors for the various characters. In this case, it's just 16 colors. There are ways to expand the number of colors, and a lot of terminals, including the one I'm using, do support that. But in this case, I'm not using those just for the sake of simplicity here. Then I've got this char style enum, and it's not really been implemented very much at all. It's really just here as a placeholder. I have a character structure, and this stores all the information about a single character. So the display character, in this case, it can handle up to 4 characters. And also the character itself can be 4 bytes. So this is able to store a Unicode character. Then I've also got the foreground and the background, and the style. All this is for every single character. Every single character on the screen that you can see right now has one of these representing it. I also had to make some adjustments to the text buffer itself, and so I needed a way to store all those settings. So we have here a width and height. Got the foreground and the background, and these are applied by default to all the characters in the screen. This scroll off variable, which is what determines how long for the page will move in correspondence with the cursor. Tab width, and then the character representing the tab character and the new line character. And in this case, I replaced this with something else, so this defaults to blank, but you can replace it with other things. There's a bunch of functions in here. Some of them are new. Will show you guys what that looks like once we get to the source file, but for now, I'm just going to show you guys the member variables that I added. So I added a way to store those settings here. And then we have the screen start and screen end index. And those are to help with figuring out where I am within the buffer and where I need to be printing out the screen. Cursor X and Y, but it's pretty obvious. It's to track where the cursor is. And then finally, I have this pointer here, which stores the dynamically allocated array of characters that represent the screen. All right, so now we're in the textbuffer.cpp file, and we'll just go down here. This is basically the same, a few minor changes, nothing particularly exciting. In load buffer, near the end, I allocate space for the screen variable. So in this case, I'm allocating a single dimensional array, a one-dimensional array here. Normally, when you are thinking of two-dimensional objects, you think, oh, you should use a two-dimensional array. And I don't necessarily have a problem with that, but the issue when using the heap is that if you do that, you end up having to allocate not only the two-dimensional array, but then every single one-dimensional entry within that array, which is obviously pretty clunky and time-consuming. And so the way around that is to basically just sort of fake what a 2D array does. So on the stack, a 2D array is allocated all in one go, and then it's accessed using the typical array accessor, the typical 2D array accessor setup. But that's not something you can do on the heap as readily. It does work, but it's just weird and clunky, and I didn't want to do it. So I'm doing it this way. And then I call update screen, which I'll show you guys in a minute. As a quick parenthetical, I went ahead and made some changes to resize buffer, and that is because the old method for resize buffer, which was basically just to call load buffer again, wasn't working properly. So I had to re-implement this, and I haven't actually tested it, so it may actually not work. So we'll see how that goes. All right, here we are in update screen. And the first thing that update screen does is it goes through the entire screen and sets all of the characters to a blank character. So the actual value of the underlying character would be 0, and the display character is a space, with the foreground and background and everything else set to the default. Then I go through and starting from the start screen index, or screen start index, I should say, and going until I either leave the screen, so go far enough to exceed the distance that the screen can print, or until the end of the buffer, I print out all of the characters, or I should say print them out, because I don't print them out here. I put them onto the screen buffer. And then, in this case, we create a character structure, instantiate a character object, and then figure out what kind of character we're dealing with in the text buffer itself. And then once we have that, if it's something like a new line, we do something specific here. If it's a tab character, we do something else. And if it's something other than a new line or a tab character, we'll do something else. And all the while, we're updating this screen end index. And then finally, I call the draw command. There's also get cursor position, and what that does, it's basically doing half of what the function above does. It's starting from the screen start index and going up until it reaches the precursor index. And the reason for that is that I can figure out where the cursor is in the screen, because otherwise it's shockingly difficult to keep track of that consistently. So I decided to use this method. Then we have shift up, and shift up basically is shifting all of the contents of the buffer upwards. So in this case, whenever I reach the bottom of the screen, it will try to shift up in order to move the screen up. And in this case, all it's really doing is tracking where the screen start index goes and then calling update screen. So previously I had a lot more complicated stuff working, and it was an interesting idea, but it ended up just kind of being a massive pain to do. So I found out that using update screen is probably the best way to go about it, at least for the time being. Same idea for shift down, a little bit more code because shifting down is a little more complicated. But other than that, pretty similar in concept. And then during the process of using update screen, the screen end index will be set to the proper value. Advance has changed a little bit, so I went ahead and removed the mem move here. It's not strictly necessary, but I was already using a for loop to go over the entire distance, so I figured I might as well just go ahead and do all the data movements anyway. And then if the cursor is at a particular position and a couple other conditions are satisfied, then we use the shift up command or function. And at the end, I get the cursor position, and then it sets it to that position. End and down haven't changed at all. Retreat has again changed as well. And again, it's set up so it will respect the scroll off variables. So if we're high enough if the cursor is high enough on the screen, then it will attempt to shift up, assuming that screen start index is greater than 0. And home and up are the same. Insert, I had to make some changes in order to make it so it would shift properly and update the screen. And again, same thing with remove. So basically, whenever I remove or add a new line, it's going to attempt to shift up or down, assuming that it's in the correct position to do so. Here we have some helper functions for getting the colors converted to the strings that I use in the ANSI escape sequences. This one is basically just a dummy function because I'm not really working with style just yet. And so here I create a string here that will end up being printed. And here, every time that the colors or the style change, it is going to call this, it's going to go into this little area and add in an escape sequence to fill in that changed color. And then it puts the display character in place, and by the end, it will print everything out. So it'll print out the clear screen escape sequence, then put all the content in there, and then move the cursor to the correct position. And that's everything in textbuffer.cpp. Right now in main, pretty much very little has changed, but I did add this sys/ioctl.h function, this header. And the reason is because I need the ioctl function in order to determine the size of the terminal that I'm using. So if you use this function call with this little, I think this is an enum, then it will return a structure that contains the size of the terminal in width and height of text. So I just put that information into my settings, along with the colors that I want, and the character. In this case, I'm replacing the tab character with this little arrow thingy here. So these are the character codes that are needed for that. And then the only other major change that I've made is that this run loop doesn't actually directly print out the buffer anymore. It doesn't need to. It just calls to the text buffer, and the text buffer will decide if it needs to print. So rather than having the program just constantly printing, which was making things look a little weird, so if I were to try and highlight a bunch of stuff with the mouse, you would notice that before it would just kind of freak out. Now, it doesn't freak out. That is basically everything. So now I have a working draw buffer with some caveats. There's some things I haven't completed yet, but it's at least as featureful as the last drawing solution, and it's much more featureful in some important aspects. And so in the next episode, I am going to tackle Vim bindings, at least as much as I can. Up to this point, I've kind of stuck with using the more standard bindings, kind of like Nano, but I prefer Vim bindings, so that's where I think I'm going to start working on those. So thank you very much for watching, and I hope you found this interesting or useful, and I'll see you in the next episode. Goodbye.